Our amorphous C cores, often referred to as cut cores, are a go-to when low core loss, reduced size, and high efficiency are priorities. They are made up of ultra-thin ribbons of amorphous metal, typically between 13 and 25 microns thick. It is continuously wound on a mandrel, forming a rectangular core with rounded corners. We handle these cores with caution, as the brittleness and thinness of the amorphous ribbons make them very fragile. With every part of the process, from manufacturing to storage to installation, these cores must be handled with care. To ensure the amorphous ribbons don't spring apart, we impregnate each wound core in high-temperature epoxy. Once cured, these cores are cut into 2 matching C halves. We cut these cores because it allows coils to be pre-wound on bobbins and then assembled over core halves, which results in much easier assembly than winding directly on the cores. It also allows for a controlled air gap that makes for better magnetic saturation management. To cut, we use a diamond grinding process opposed to sawing, as the grinding process is more delicate on the material and results in a smoother and more polished mating surface. The surfaces are then aligned and often marked during manufacturing to ensure proper reassembly and minimal magnetic gaps once coils are installed. Now, even with proper handling, some visual characteristics can appear but are harmless. Flaring can happen, which is when ribbon layers along the inner or outer edges may look slightly loose. Or the ribbon side surface may show some minor unevenness, small gaps, or epoxy accumulations. Not to worry, these are simply cosmetic and in no way impact functionality. The same goes for how the cores are measured. As they are not machined parts, their dimensions are not perfectly linear, making it difficult to use traditional caliper measurements as used with machined parts to accurately portray dimensions. Instead, we carefully perform a dimensional inspection with visual and photographic references to ensure they are up to standard. Let's compare traditional EI or UI laminations to C cores. At first, it looks like EI and UI cores are cheaper, have more standard sizes, and slightly lower losses than C cores, an effect of the intentional air gap. However, amorphous C cores make up for this by having higher magnetic efficiency, lower no-load losses, and reduced stray magnetic fields. Their long-term performance benefits justify the investment. Also, compared to conventional silicon steel cores, amorphous C cores have slightly lower losses and improved efficiency, especially in applications where no-load loss matters. At Hill Technical Sales, we're here to help you evaluate trade-offs, select the right core, and apply it correctly in your design. If you are considering amorphous C cores for a new project or troubleshooting an existing one, we're here to support you.